Hi, hello everybody, and welcome here at the KTH Library to this presentation called Software, Exploring Feminist Entanglements of Software and Knitting. My name is Nadia Campo-Wojtak. I'm an artist, designer, and researcher at the Media Technology and Interaction Design Department at KTH. And my research focuses on feminist approaches to technologies. And today I'll be talking about my project called Software, where I've been exploring the intersections of software and computation and knitting. And I call it an exploration because this work doesn't aim to answer or close any questions, but rather it introduces new, it doesn't really aim to introduce new and innovative technology or solve a problem. Rather, it brings together things that might seemingly be, belong to kind of different categories and be unrelated. And it's building on many different voices in different fields, such as design, art, and software engineering. And I'm bringing all these voices together to kind of tell the stories and tell conversations and have discussions. So I do really encourage you to leave any questions or comments or thoughts, or even if they're unformulated thoughts, in the chat, and we will address them and look at them towards the end of the talk. So for the past year, I've been working as a software artist at a collective called Rethread. And at Rethread, we are a group of artists, designers, and computer scientists, and we work with software art. And we're located here at KTH within the software engineering department. And what we've been trying to do for the past year or so is making sense of software through art. So software itself is really hard to define. It's kind of hard to separate and delimit. It's hard to even see or feel it. And we aim to communicate and express what software is, and that it is all around us, that it permeates the world, that every digital device and thing has been sort of touched or entangled with software. And it's different from code because it's not just a piece of code sitting on a server. It's not static, but it's in constant flow. It's like a stream. It's in movement. It's like execution. It's the code that's being run. So I like to show this image on my slides to explain the complexity of defining software. I asked my colleagues in the software engineering department a while back what was software, and to draw their answer within 5 minutes. And the variety of the answer, there's like a wide variety of different drawings that people made. Like they used metaphors, connection. There's a lot of humans, machines, and codes, and different mechanical structures. There's one that even is about software is the shadow of a tree, for example. And so this goes to show how difficult maybe it is to define what software really is. And through art is how we really intend to provoke these sort of reflections on the nature of software. So the project that I'm going to talk about knitting, began when we ordered a knitting machine at the lab that I'm currently working at. And I've been manually knitting on and off during my whole life, but this machine was new to me. And I was lucky enough to be part of the group of people that were unpacking it and putting together the machine, so I spent lots of time learning about each part and getting to know the different techniques and what was possible and what was not possible with the machine. And so the way that the machine works is that it knits one row at a time, and the carriage, which is this thing that kind of moves back and forth, so you can see in those small clips that I was moving this kind of thing back and forth, and that's what kind of changes the position of the needles and knits a row each time, and then grows. There's a big piece that kind of grows underneath it. And so there's a lot of manual labor still. And it's very delicate. It's actually very frustrating when you mess up with the knitting machine, because sometimes it's even easier to just scrap your whole piece and start all over again to fix the issue. But there's still a lot of manual work involved. And so the real potential of the knitting machine comes also with this quickness of being able to knit much quicker than manually knitting, but also with pattern making. So knitting machines use punch cards that make these patterns. So here's an example of a punch card where it's literally just holes punched into a card, and a hole or an absence of a hole symbolizes two different colors. So it's a very binary thing. So it's like one color, another color. It's a hole or not a hole. And although our machine, the machine that I was working with doesn't actually work with punch cards, it came with a software that allowed you to import images and draw different patterns and then send that to the electronics of the knitting machine. So it's an electronic knitting machine. And it allowed you to kind of export these to the machine. So the way that I used the machine then was through the software that we bought. And I would import an image into the software, and then that would send it over to the machine and move the needles accordingly. And there are open source alternatives to this software and this hardware, but unfortunately, these weren't prepared actually for the specific model that we had. And I also kind of lacked the skills myself to make this software or this hardware myself. So I was using the software that came with the knitting machine. So one of the pieces that I chose to exhibit at the KTH library explores these different layers of communication from going from the human to the machine, to the knitting machine. So I coded an algorithmic pattern called Cellular automata with a framework called P5JS, which is a very open and accessible framework. And I knit this image. And a cellular automaton, I won't go much into the details of it, but it's a pattern created on a grid of cells, and the next row is determined according to a set of rules based on the neighboring cells. So it generates this kind of very beautiful pattern. And exhibited here at the library, I exhibited the code that I made to generate this pattern, and then next to it, I also exhibited a big long stream of code, which is actually a format called JSON. And this is actually the stream of like connection between the computer and the knitting machine. So this is like kind of all the messages that the computer was sending the knitting machine. Each time there was a new row, it was sending the exact kind of colors that should be knit each row. So back to the idea of punch cards. As I said before, some knitting machines work with punch cards. These similarities between software and code and knitting already began in the 1930s when the invention of one of the first computers, which is called the analytical engine, which you can see here on the right. It kind of paved this invention paved the way for all our modern computers nowadays, actually. And it worked off of punch cards. So the designer of the machine, Charles Babbage, was mainly inspired by the Jacquard loom, which is the picture on the right. And the loom, which is another invention very similar to the knitting machine, it used punch cards to create patterns in woven fabrics. And so in the analytical engine, the punch cards represented sort of different numbers and different instructions or data that could be inputted into the machine. And the use of punch cards followed all the way throughout the history of computer science. And many times the manual labor of punching the cards or translating the programs was actually done by women. So here we start to see these kind of gendered associations that we might have nowadays associated to these two fields, textiles and computer scientists. They've actually been very blurry throughout history, and the very origins of computation and computers are very much intertwined and linked with the origins of fabric creation and knitting and weaving. So this brings the inspiration to the second piece that I have exhibited here at the library. So the second piece in the exhibition is inspired by this shared history, and specifically by this woman called Ada Lovelace, who you might recognize since she's played a big part in representing women in tech and in computer science in the past years. Her name was, as I said, her name was Ada Lovelace, and she assisted Charles Babbage in the design of the analytical engine, that first computer. And she created a set of notes on how to program the machine. And her most famous note was called Note G. And this calculated a mathematical sequence called the Bernoulli numbers. And because she did this, because of these notes on how to program this computer, she was known, and she is still known, as the first computer programmer. So my colleague Nicolas from the software department and I collaborated on this piece, and he translated the original Note G, which was that table that you kind of saw in the slides, into a graphical representation that could be knit. And sort of I went back and forth. It was a collaborative process where I informed him the way that the representation would be best and easiest to knit for the knitting machine, and that might cause like less snags or less manual labor. So it was kind of a collaborative, iterative process of going back and forth and finding out the best representation. And then we chose the length of a trace. It could have been longer if we had chosen to use more input parameters in the algorithm, but we chose a length that was approximately about 3 meters long, I think. And it actually took me about 8 hours to knit this whole piece. And here's a little picture of me like holding it outside of a window, trying to show the scale of this piece. And so this piece is on display at the KTH library along with Nicolas' code. And what I really like about this piece is that it's a meeting between these two worlds that are seemingly really different. My colleagues from the software group, when they came to visit it, they were really fascinated by the numerical representations and kind of the length of the piece. And they would go throughout the piece and kind of look for hints of the algorithm. And then my friends from the design group were very interested in kind of the steps of translation between human and machine and the algorithm and the physical and the tangible, and also the aesthetics of the pattern itself. So I really liked it because it's kind of this unitedness of these two kind of seemingly different fields. So moving on to another intersection of software and knitting. Many people who use manual knitting patterns and who are also coders can't help but notice the similarities between a knitting pattern and a computer code. So here's an example of a manual knitting pattern where there are different repetitions and there's a set of different instructions and abbreviations that together form some sort of pattern on a fabric. And this really does look like a piece of code. And so some artists and scholars, by cleverly combining the different stitches, have actually been able to create different codes that represent language, that represent letters, and allow you to sort of encode a secret message into the fabric. And this has actually been seen throughout history again, especially during the Second World War, when women, especially older women, took advantage of the stereotype of the little old lady sitting and knitting, supposedly doing no harm. But rather she was actually knitting data about, for example, the Nazis' trains that passed by her window into the actual piece of fabric. And then later she would take this piece and give it to her fellow soldiers, who then they could actually unravel the knit and kind of destroy the information if needed. So this idea of storing data was actually the focus of a workshop that I was going to host on Thursday, but we've had to cancel that because of the recent restrictions of COVID. But it is something that we might be able to do in the future. And if you're interested, I made a tool to support this kind of, it's a very simple tool where you write a message and then it translates it to binary, and it shows a little way that you could have a pattern, a knitting pattern that you can manually knit that includes this message in your knit. So in terms of unraveling, this is a bit more on a conceptual side. Knitting was also very interesting because it allows you to unravel a knit and kind of reuse it for something else. So for example, I know a lot of knitters who use like their scrap pieces, like the ends of the yarn, to make new things, to make like a piece out of recycled yarn, for example. And like I've done this with some like a small loom, and trying to kind of reuse these pieces. And this is especially relevant when you have like a bug or an issue in your pattern. And this is what happened a lot during knitting with the knitting machine, because it got caught a lot in the needles, and especially at the beginning when I was learning. And so this could prompt one to think about the kind of similarities with the this kind of dynamic nature of software that I mentioned at the beginning, which is different from hardware, because hardware is something that, for example, is maybe soldered in place. It's like an electronic component. It's kind of stuck there and you can't move it. But software is something that can be changed. You have a memory, and whatever you put in this memory, you can always change as long as you have kind of this this box that you can use, and you can shift it around, you can make something new. So for me, that kind of felt like very similar to a string. Like you have a string and you have a set of knots within it, and then you can unravel it and create something completely different. So that I kind of wanted to open up this question of like, so what can we learn from understanding that these two materials, software and knitting, or software and thread even, share this kind of dynamic quality of movement and fluidity and remaking. Right, so back to kind of investigating the ways that data and code and software might be stored in textiles. Actually, my research took me back to the early computers of the 60s or 70s, which sometimes used a technique called core rope memory or magnetic core memory. And this involved using copper threads or wires passing either inside or outside different magnetic rings or openings in order to code ones or zeros, so in order to code a bit. And once again, this is a very close relation to textiles, both aesthetically in the way that you can see in these images how it really looks like textiles, but also in the way that they were built. So magnetic core memory was actually used during the NASA's early Apollo missions to the moon, since it was supposedly a very robust way to store data and it would resist space travel. And what I really love about this technique also is that it kind of blurs the idea between hardware and software that we have nowadays, that, you know, hardware and software are very different things to us in modern computers. But here, the software kind of is the hardware. It's like hard-coded into the blocks. So depending on the way that you kind of like wove or crafted these structures, the software would stay in that structure. And so it was a bit like programming. The act of programming was actually the act of crafting as well. And so these blocks, again, were meticulously woven by women. And I was greatly inspired by Daniela Rosner's work on shedding light on the hidden labor that went into creating these blocks. And the NASA engineers said that they nicknamed this hardware the LOL memory, for little old ladies, who carefully wove the wires around the small electromagnetic ferrite cores by hand. So if you're interested in learning more about this kind of hidden labor that, about these blocks, I really encourage you to look up Daniela Rosner's work. So on this note, in our interaction design lab, there's been several people that have worked with conductive threads and e-textiles and conductive yarns. And so I found that these were actually really easily knittable by the machine. And it allows you to create a sort of different like touch sensors or stretch sensors or different kind of soft and flexible systems that that might be different from like hard or like 3D printed or sharp materials. So a work that I have not exhibited here at the library but is still unfinished and open is an exploration of knitted speakers. And here you can see a few examples of knitting with conductive thread in different ways and obtaining a small area that acts as the speaker membrane actually. And a speaker, so the way a speaker works is that it's a very basic circuit. It includes a magnet, a membrane, which in this case is the knitted mesh, sort of, and the sound signal that comes from an amplifier circuit. And it's connected to either side of the copper knit. And so here's a small video. Hopefully you might be able to hear a little bit of sound. All right, well, it's a very lo-fi speaker. It has a very low volume, and but it becomes very clear when you're kind of pressing it to your ear. And I thought this was super interesting because it's a lot more like intimate in like interaction, which is actually what you have with cloth and textiles, right? They're close to your skin. So it's kind of turning this hardware, this thing that is usually like hard, maybe it's a speaker, into something kind of soft that could be also wearable. So I've put this circuit and a few other examples of knitting conductive thread here on display in the library in a sort of physical collage. And right next to this collage and kind of the final piece of this exhibition, excuse me, is a small connection of swatches called symmetries. And these swatches are an exploration of randomness and symmetry and kind of an ode to the aesthetics of the magnetic core memory blocks that I've just mentioned. And displayed with these swatches is a screen and computer which actually runs the code that generates these patterns in real time. And because of the immense amount of random possibilities, it's actually very unlikely that you, or very, very unlikely actually, that you see the same pattern twice. Yeah. And so as I'm ending or nearing the end of the talk, I'd like to bring up two different quotes that I have related to my own practice and experience in this work. So within my own work in the software research group, I've constantly kind of found myself having to maybe justify why these intersections are interesting. How are these things even connected? Why are you looking at knitting if maybe you should be looking more at software specifically? How is this connected? So for me, it's about keeping these stories alive. So when connecting things like this, it's keeping these stories alive, helping us to understand where we are now in the present, what we can do. And personally for me, as a bit of maybe an outsider in the software group, it really made me feel closer to the work that's being done there. And this really specialized work on software engineering and how this technology works and how it's been built. And it's a bit of sort of like demystifying it for me, which I find lacking in a lot of the technologies that we use today. So when Ada Lovelace explored the first computer, she herself noted the importance of this connection. And she said, the analytical engine weaves algebraic patterns just as the jacquard loom weaves flowers and leaves. And I also feel that this work is very much in line with what scholar Sadie Plant says in her book, Zeros and Ones. And I'll read it out to you. The yarn is neither metaphorical nor literal, but quite a simple material, a gathering of threads which twist and turn through the history of computing, technology, the sciences, and the arts. And in and out of punched holes, automated looms, up and down through the ages of spinning and weaving, back and forth through the fabrication of fabrics, shuttles and looms, cotton and silk, canvas and paper, brushes and pens, typewriters, carriages, telephone wires, synthetic fibers, electrical filaments, silicone strands, fiber optic cables, pixeled screens, telecom lines, the World Wide Web, the net, and the matrices to come. So if now I were to ask myself again and do this activity of drawing what software is to me, I would probably use a sort of tangle of threads to describe that is what software is. And so finally with this talk, I really wanted to open up questions and not solve a sort of scientific problem or give answers, but make it into a conversation. So I would love to hear your thoughts and ideas, even if they're unformulated thoughts or also personal experiences. Because while I was doing this work, I learned that the factory where the women were weaving these core memory blocks, so those conductive kind of blocks, was located in a town outside of Boston, which is very close to where I grew up. And that's actually where one of my recent good friends has relocated to. So I suddenly felt this kind of personal pull to these stories, and I hope that somehow you found some sort of personal anecdote or small link or connection, whether to knitting or to software or to design or to art. And as Ada Lovelace also said, all and everything is naturally related and interconnected. A volume I could write on this subject. Thank you so much. All right, so if you have any questions, please post them in the chat and I will bring them up here. And if not, of course, feel free to send me an email or reach out later. I'd be really happy to just hear anything about this work or what you've thought. And the exhibition here at the KTH Library is open until the end of November, actually. So it's open as long as that library is open, so you can come at your own pace and respect the distances with everyone, and it will be up for another while. Okay, I have one question. Let's see. Do you think knitting machines and computers can help us think more locally and sustainable? Yeah. So definitely, that's a really good question and thought. because one of the things that I came across a lot was that the software that the knitting machine used was actually proprietary software, and this means that it is a that you have to buy and you have to pay, and it's owned by one company. And so there are many open source. So this is the difference between open source and like proprietary software, right? So open source software is like free and accessible for everyone. It's usually online, and you can kind of use it yourself and connect it even to your own programs if you know how to do that. And so for this specific machine, there weren't any open source solutions, but I think what I'm getting to is that I think if there were more solutions like this, more open source solutions to knitting machine softwares, it would be much more relevant to like have one of these machines in like maker spaces, or like say here at the KTH library, you could have a machine and that's shared among a lot of people, and you come and you kind of make your own clothes. And so of course, making your own clothes, it's talking about this kind of self-sustainable kind of economy. It's towards like maybe even recycling and using local products and local yarns. So I definitely think there's something kind of to tie into sustainability and the fact of like producing your own clothes and learning how to make your own systems and your own software as well, right? Yeah. So I hope that helped. Okay, how can a non-expert play with this kind of knitting? So I mean, first of all, I wouldn't define myself as an expert either, especially not in knitting, because this is something that I learned in the past few months, just exploring the machine. So I do know that these kind of knitting machines are available at some maker spaces, so maybe that's a place to try to find the access to one of these machines. But then something that you can also do is that there's so many resources online on how to manually teach yourself to knit, and then maybe using the tool that I had talked about of like knitting binary code or something like that. I think that just with this act, it kind of helps you like really see, like understand maybe the structures of computation. It helps you like bring up these questions and reflect. So I think definitely playing with manual knitting and knitting binary is a really interesting and simple exercise that could be done. Okay, so I'm getting some other questions, and these are all private, unfortunately. I would have liked if everyone else could see them, but I'm just gonna read them out if that's okay with everyone. So what is the next step? Have you considered releasing the patterns for other knitters to explore and build on hand or by machine? Yeah, so that's also ties into this idea of like open and accessible code, right? And so the code that I use to make the patterns is actually open source and it's accessible. And I actually used a lot of other open source things to build on it. I didn't build it from scratch. So I'm really building on things that already exist here. And so definitely that might be the next step regarding making these things public, but yeah, I definitely want to continue working with the knitting machine somehow, and I think the next thing that I really would like to explore is continue with the knitted speaker, because that I left kind of open. Okay, so another question is, in the future, do you think people will be able to program computer code through knitting? Okay, that's an interesting question. Do you think the kind of code that we make might be different if we knit that computer code? I don't really know how to answer that question, or I guess it's a reflection, kind of an open question. But I definitely think that knitting, since it has a different temporality also than software, which is super fast and quick and like efficient, and sometimes when we like solve a software problem or something, we're really trying to make it as efficient as possible. But knitting, on the other hand, especially manually knitting, is not so much about the quickness of doing it, but it's about the enjoyable experience of knitting. I know a lot of my friends and colleagues who are knitting while they're listening to Zoom calls. I really hope that someone's doing that actually now, listening to this. And it's really something about just the enjoyable, test this, the tactileness of it. And so maybe there's something there that, I don't know if this relates so much to your question, but maybe there's something there that computer science could learn from in perhaps these kind of more slow or attending to the kind of sensations and things like that and the physicalities. So yeah. So some people have been asking me to introduce some of these materials. I can post some of these on the blog and the website that I've been using. So if you just go to nadiacw.com, that's my website, /software. I can post something after the talk, like a link, maybe if this is being recorded or something. I can address those questions there. And maybe I can take like a final question to kind of wrap up a bit. So I've been asked, what is the most fun thing about working with the knitting machine? I guess, like for me, it's really just been this whole work that I've described is discovering these interconnections, and to be able to like relate that to my identity also as a woman in computer science, and kind of, yeah, being able to find that something, that doing some craft is very close to programming as well, and kind of connecting these two worlds a bit more. So it's not so much about, maybe it hasn't been like the most fun thing about knitting hasn't been like an actually like task or something, but it's been more this kind of realization and having these conversations and things like that. So I think if there aren't any more questions, I might wrap it up now. And please do feel free to send me an email. I can write my email again in the chat before we close down. But yeah, thank you so much for joining here at the library. And I do hope you do come and visit if you have the chance and if you can. But thank you so much for joining, and hope to see you soon.